Welcome in everyone. In this video, I'm going to go over how to estimate areas under a curve with rectangles. Now, really what matters when you're finding the areas using rectangles is the number of rectangles you are asked to use, which will then help us figure out the width of each rectangle. And then the height of the rectangles is based on the function and ultimately whether or not we're using the left endpoint, the right endpoint, or the midpoint of the rectangle width. Let's take a look at an example. On this slide, we're going to estimate the area between the x-axis and the function f of x equals negative x squared plus 16 on the interval from -1 to 3. And we're going to use 4 rectangles to do this with right endpoints. So what this means is that we will be uh, segmenting this interval from -1 to 3 using 4 rectangles. Now you can find the width of the rectangles simply by subtracting the largest value of the interval, which is b, minus the smallest value of the interval, which is a, and then divide by the number of rectangles, which is n. So here, n would be 4, a would be -1, b would be 3. And when you do that, 3 minus -1 all over 4 is 4 over 4, which is 1. So each rectangle has a width of 1. And so we can't find that width until we know how many rectangles are there, but that's how you can find the width of each rectangle. So down here on the graph, I know each rectangle is going to have a width of 1. And you can see that one rectangle would be here, 2, 3, 4. Now from there, I said on the last slide, you would have to know whether or not you're using the right endpoints, the left endpoints, or the midpoint of each of these rectangle intervals, each of these rectangle widths. So you can see that since we're starting with the right endpoints, what that means is on this rectangle here, the right endpoint would be 0. For the second rectangle, the right endpoint would be 1. For the third rectangle, the right endpoint would be 2. And the last rectangle, the right endpoint would be 3. So what does that mean is we need the right height of that interval. So that means the rectangle here between 2 and 3 would be this tall. So let me just go ahead and draw in that rectangle like this. That means the rectangle between 1 and 2 would be this tall because that value of 2, that y value, is at the right of that interval. So let's make this rectangle. Let's make this rectangle very similarly for the third one, but the last rectangle here looks something like that. Now with this, you can tell that this is not going to give us an exact area because there's some underestimation here. This rectangle, the second rectangle, leaves out this little bit of area. This third rectangle leaves out a lot more area. So this is an underestimate just in this column, we'll say. There's a big underestimate here. It leaves out almost this entire triangle looking piece. But over here, the area gets some of that underestimation back. But that's it. All you'd have to do then is multiply the width times the height, which you can figure out just by substituting these values into the function. So the height of this rectangle here is 16. The height of this rectangle here is what you get if you substitute 1 in here. So -1 plus 16 is a height of 15. The height of this rectangle here is what you get when you substitute 2 into the function. -4 plus 16 is 12. And then this last one should be 7. So then we can multiply the width times the height of each area, and then add all of these numbers up to get the estimated area of, let's see, this is 31, this is 19. It should be an estimated area of 50. And in fact, it should be 50 units squared. Now, I could have very easily come along and said, okay, well, we don't want the right endpoints, we want the left endpoints. And so what that would do is it would say here, instead of looking at the right side of this interval for the rectangle, we would look at the left side of the interval for each rectangle. So the left area here would be this yellow rectangle, this yellow rectangle, this yellow rectangle, and this yellow rectangle. So it's a lot more of an overestimate at that point. But again, we can go through and figure out what all of that is, right? The first rectangle will have an area of 15. We already know it's 15 tall. The second area, or the second rectangle, will have an area of 16. The third area will also be 15, and then 12. And you can see this number from the left endpoints should be a lot bigger because the rectangle not only includes the area we need, but a lot of extra area that we don't need. So this yellow area, or this yellow estimate, should be a lot larger than what we got for the red estimate. So 15, 15, 16, and 12 is 58 units square for the left endpoint estimate. And then finally, I could have also asked at some point, hey, what is the midpoint estimate for these? Which means you would have to find the number in the middle of all these intervals and then use those numbers to find the heights of those rectangles, which does get a lot of fun because decimals or fractions are involved. Um, Let me move over to another slide to show you what that would look like. So just to show you what the midpoint would look like here, again, we know that there would be 4 rectangles here. The interval is still from -3 to 1, or sorry, -1 to 3, and the function is still -x squared plus 16. But if we're trying to find the midpoint, that's this number right here, -0.5, this point right here, 0.5, this number right here, 1.5, and this number right here, 2.5. Now, why would you ever pick the midpoint? Because when you follow -0.5 to the top to the actual function here, it lands right in between the left and right interval, which means there's a little bit of an overestimation here and a little bit of an underestimation here. So we can at least draw the rectangle in. Let's see, 0.5 would be right there. Same thing. There'd be a little bit of an underestimation here and a little bit of an overestimation there. That's okay. Let's see here, 1.5 would be right about there. And the same thing. This might actually give you a more accurate answer for this particular function. And it looks like it might because this rectangle here doesn't count this area, but does count this area. And my graph isn't perfect, but they look like they pretty closely offset each other. Not completely, but pretty closely. So how do you find these heights then? You have to substitute -0.5 in for x in the -x squared plus 16, and this number, and this number, and this number, but the width of each rectangle is still just 1. So when you go figure out f of -0.5, f of 0.5, f of 1.5, f of 2.5, you get all of these decimal numbers here. but then you have to multiply each of those by 1 because that's the width of each rectangle. And when you add all this together, you get 55 units squared, which makes sense. If you go to the midpoint, you end up with something that's between the left interval or the left estimate and the right estimate. And of course, I could change the number of rectangles and more decimals would appear, but that's just part of how this section works. All right, I hope this video helps you out, and I wish you all luck.